So here I have a typical midstream or transmission system. I've got some gathering lines here in the northwest section. I've got the long main line that runs, moves this product down to its ultimate distribution center here in the Houston area. And so this is a typical linear referencing system. I've got my mainline valves and pumps along the way. But interestingly enough, what I've been able to do is underpin this with the utility network. And as we zoom in here, you'll see some things that are a little bit different. Here we have a typical pump station for this facility. Let me turn on the base maps to give it a little more context. So here what you're seeing is a combination of both stationed and non-stationed pipe. So the main line here is in our linear reference system. It has engineering station and calibration points that we would normally expect. But as we enter the inside the fence piping here, I'm now jumping over and using the utility network functionality to connect up all this non-stationed pipe and really complete the full picture of what's going on at this facility. You can even see here inside this building, I've got some pumps and some meters. And initially it may look like they are actually disconnected from the network, but here I'm using the utility network's containment functionality. And I could actually go inside this building, not only inside the fence, and see all the objects that are connected together to build up this facility. So these are all brought in from a 3D CAD as-built drawing, and now I have full end-to-end connectivity for this entire system. I can enter that, can exit that containment and go back to the facility view. And what I'm going to do here now is show you how all these objects are actually connected together in a real-world example. In this use case, what I want to do is I want to come out of this pump system here, and I want to find the limiting MAOP of design device that exists along this system. And to do that, I'm going to do a simple geoprocessing trace routine. I'm going to look at my pressure system. I'm going to look at that specific pressure system coming out of this pump. And as I iterate over those components, I'm going to look for the minimum MAOP design of any fitting or any pipe component along the system. I'll go ahead and run that trace. And when these results come back, if I view the details, what I'll see under the messages here is that limiting MAOP along that entire system. So you can here see now the final results of that trace. There is a component out there with a minimum MAOP of design of 500. And you can also see on the map here, all the pipes and all the fittings that were discovered during that trace are selected. And if I zoom back out here a little bit more, we could actually see the entire extent of that selection set all the way down through all the other components along that transmission system down into the next downstream pump station. So even at this level, this can be difficult to understand exactly what's going on here. I've got a lot of components here at the station and a lot of other additional components strung out over this long mainline section. So what I'm doing here is I'm taking this entire system and then using another functionality of the utility network to create a single line schematic or diagram of this entire facility. So now I see an end-to-end diagram of all those components, but more importantly, I can take this selection set here from the map and I could actually apply that to that diagram. So now when I switch back to the diagram view, I'm going to see all those components that were discovered in that trace. So I can now clearly see how those things are laid out within that facility and how they interact with the rest of the system. But more importantly, all these devices in the diagram are also connected to the underlying attribute data. So here what I'm going to do is I'm just going to label all my devices by their design pressure. So now I get a quick look at all those limiting design factors for all those components. And here you can easily see that that meter in that pressure system is my limiting device along that way. And so conversely, I could select this meter and then apply that back to my map. So now if I go back in here, my mapping view, there's that meter. Let's go ahead and show all the contents of that station again, turn on all those detailed facilities. And as we zoom in, we can clearly see how that meter and that pipe run is connected to the rest of the system. But even in this view, this can be a little bit complicated. The data that's inside this building was actually put into the utility network from an as-built, 3D as-built CAD drawing. So all these objects in this model have Z elements associated with them as well. That also carries through the site piping that was brought in from a civil 3D drawing. So all these pipes are actually entered into the GIS with their true elevation as well. And so one of the interesting things is I can take all this pipe from the utility network and the linear referencing system and add that to a 3D scene. So now I get a different representation of what's going on here at this facility. I can easily see the above and below ground piping. You can see that launcher receiver assembly here on the transmission system. Here's that 3D as-built of that station. And if I turn off the imagery, we'll actually be able to see all the underground piping as well. So this is the direct feed for the objects in the utility network. I haven't had to make a copy or represent this data in a different way. If I add pipes or I add facilities to the 2D map, I'll easily see them here in the 3D map as well. But what if I could actually peel back the surface of this building? And I'll do that here. Now I can expose actually the internals from that 3D CAD drawing overlaid with my utility network objects. And if I zoom in another time here, now I can really clearly see what's going on. I see that meter coming out of this pump assembly. I can see that crossover piping. I see those isolation valves in this station. It gives me a really good understanding of what's going on inside this facility, how things are connected together. And more importantly, all this information is tied back to the enterprise geodatabase. But to be able to do any of this, to be able to make sure that all this information I'm representing and all these detailed analytics are correct, I need to make sure that all the data that's entered into my GIS is traceable, verifiable, and complete back to the witness of installation of the as-built drawings. Very important part of this whole process.
So that's a pretty good overview of how we're using the ArcGIS utility network, visualizing in 3D and linking all this data back to the centralized system of record and having it all traceable, verifiable, and complete back to witness of installation documents in the field. Thanks for viewing this video. Thank you very much.